So in the previous class, we discussed about cube root of unity, in which we find it out that there are three cube roots of unity. One is 1, another one is omega, and the omega square. So if we add 1 plus omega square, then definitely, as they are the roots of this particular quadratic equation, so they are going to be 0. So this is one important property, and from here we can derive one fact that, and also we have earlier talked about omega raised to power 3 is 1, and it is the same with every multiple of 3 raised to power omega. So if 1 plus omega raised to power r plus omega raised to power 2r is given, then it's going to be 0 if r is not a multiple of 3. If r is a multiple of 3, then this and this will become 1, and hence 1 plus 1 plus 1 will become 3. So there are two conditions to consider here, and there can be two contingencies, and there can be two answers for this particular expression. Discussing about second property, omega cube is equals to 1, omega raised to power 3r is equals to 1. We have already discussed about it. If this is 1, so omega raised to power 3r plus 1 becomes omega, 3r raised plus 2 becomes omega square, where r is a integer, any integer. It always forms an equilateral triangle. What? If we map the three cube roots of unity, that is 1 is 1, 0, basically. 1 is a complex number, 1 plus 0 iota. If we take another complex number omega, another omega square. So they are always going to form a equilateral triangle. Okay. What? Cube roots of unity are always going to form a equilateral triangle. Discussing about the next property, z cube raised to power 1 minus of 1 is equals to, if there are like three roots of it, 1 and omega square, definitely the equation can be written in this format. Clear? Any doubts? Let's come to the next question. Next property. Roots of equation z square plus z plus 1 is equals to 0 are omega and omega square. We have already discussed about it. That its roots will be omega and omega square, where omega is minus of 1 plus root 3 iota divided by 2, and omega square is minus of 1 minus of root 3 iota divided by 2. And also in questions, we have to be aware about what is minus of omega. So what will be its minus? Minus minus becomes positive, plus minus plus becomes negative. So this is minus of omega, and minus of omega square is 1 plus root 3 of iota divided by 2. Now these two particular expressions will be seen by you in the questions many of the times. So that's important too. No problem, Rishi. So that's important to note. Cube roots of minus of 1. So we have earlier discussed about the cube roots of unity. There are 1 and omega square. Whereas if we find out the cube root of minus of 1, they will be minus 1, minus omega, and minus of omega square. So if you want me to explain, let me do it. So actually what we are finding out is the cube roots of minus of 1. So basically it is a equation x cube is equals to minus of 1. X cube plus 1 is equals to 0. If we take 1's cube, because 1 is equals to 1 of 1's cube, so if we further solve this algebraic identity, so this becomes x plus 1 into x square minus of 1, sorry, plus of 1 minus of x, because a cube plus b cube is a plus b into a square plus b square minus of ab. No, I guess there will be a negative sign with b also. Let me think again. Let's take an example and see. 2 cube plus 1 cube. So 2 plus 1 into 4 plus 1 minus of 2. If this is the algebraic identity is correct, then our LHS will be equal to RHS. 8 plus 1, 9. This becomes 3. 4 plus 1, 5. 5 minus 2, 3. Yes. So, yeah, our identity is correct. that we are thinking of. So accordingly, if we solve it for x is equals to 0. So one root is x is equals to minus of 1. And another roots are x square minus x plus 1 is equals to 0. Now if we solve for this, minus b is what? Um, b is minus of 1. So minus of minus b becomes this plus minus b square. 1 minus of 4ab. So that becomes upon 2a. This becomes 1 plus root 3 iota divided by 2. Now basically what is this? This is 1 plus root 3 of iota divided by 2 and minus of, sorry, 1 minus of root 3 iota divided by 2. This is basically what? Minus of omega square. This is minus of omega. Let's go back and observe. Yes, this is minus, this was minus of omega. This is minus of omega square. So what three new roots of minus of 1 are? One is minus of 1, another one is minus of omega, another one is minus of omega square. Any doubts, anyone? Okay, I guess no. So this property is also clear. The conjugate of omega. Conjugate means when we change the sign of imaginary part. Now the imaginary part sign is plus here. So if we take its conjugate, its sign is going to change. Okay. If its sign is going to change, then it can be written as omega square. So basically this is the conjugate of omega. And if we take conjugate of omega square, then this particular sign will become positive, and hence omega square conjugate can be written as omega. So this is that property. If you have any doubts, please ask at any point of time. Coming to the next property, a plus b omega plus c omega square is equals to 0. Okay, today is Sunday. Sorry, I didn't announce the class, and I also forgot to take the permission from uh, sir. And okay, that's why I'm realizing that people are coming late. Okay, but sorry, I forgot today's Sunday because there are no Sundays and Mondays in the life of an aspirant. Okay. Sorry for disturbing you all, but our syllabus is lagging behind, so we needed to do extra class for sure. But sorry that I didn't announce it earlier. Okay. Let's now go to the next property. A plus b omega plus c omega square is equals to 0. Only and only if a is equals to b is equals to c. And ABC are real numbers. Let me give you an example. If I say 2 plus 2 omega plus 2 omega square, so we can do one thing. We can take 2 common and 1 plus omega square. Now we know this is 0. So this whole will become 0. So basically the point is the coefficient of all the terms here has to be equal so that we can take that common, and then it's going to be 0 only. Clear, any doubt?
No, sir.
Okay. So let's go forward, and we have discussed about the cube roots of minus of 1, that are minus 1 minus omega and minus omega square. So we have discussed about all of the properties. Some are remaining. So its root of its root were omega and omega square. So let me write it like this. If this is a equation, hmm, if this is the equation and its root are, we know 3 and 1 plus 3 and 1. So it can be written as x square minus of 4x plus 3 can be written as x of minus 3 into x of minus 1. And similarly, its roots are omega and omega square. So this can be written as this x minus omega and x minus omega square. Its root are minus of omega and minus of omega square. So it can be written as x plus omega and into x plus omega square. Clear? Any doubts, anyone? Are these two expressions clear?
Yes, sir.
Yeah. Now let's coming to the third property. Now this is very important. We have discussed till now in the algebraic identity that this is x plus y into x minus of y. Now this time we are also going to discuss about x square plus y square. Let's take the RHS to solve whether this is true or not. So x multiplied to x, that becomes x square. X now this multiplied to second term of this particular term. So this becomes xy into iota. This into this becomes xy into iota minus iota square into y square. So this term cancels this terms. Iota square will cancel the negative sign. So it will become x square plus y square, which is the left hand side. So this is also an important equation. Clear? Any doubts, anyone? Any doubts? No doubts? If there are any, you may ask. Okay. So let me explain it in a different manner. So if say, let's say z is a complex number x plus iota y, then what is its conjugate? Anyone? What is the conjugate of a complex number x plus iota y? I'm asking about conjugate. No idea, anyone. What is the conjugate of a complex number? Okay. Today is Saturday, not Sunday. My God. Confusions. I was about to text Gupteswar sir. Anyway, the conjugate of a complex number, it's just the same complex number, but just the sign of imaginary part will be reversed. So the sign is of imaginary part is positive here, so it will become negative in the conjugate. So x minus of iota y. Clear? So now if we further look into it, so what is just happening is we are multiplying the conjugate of a complex number with the complex number. So it will become the modulus square. What is the modulus? Modulus is root of x square plus y square. This is the modulus. If we take square on both sides, so this becomes a property, which we discussed earlier also. Okay, important. Properties are very important because these are the only things which are going to help us in questions. I'll move forward. Interesting. So, yeah. Now we have to discuss this question. So, as we know, what is an iota? Anyone? You just tell me these four answers, and I'm going to tell you the full solution of this question. What is iota? Are you sleeping, guys?
One.
What is iota? One.
Iota is root minus 1, sir.
What is iota square then?
1.
What is that?
The minus 1.
What is iota raised to 4? Its square 1. So 1 plus iota square is minus of 1, plus iota raised to 4 is 1, plus iota raised to 6 is minus of 1, plus 1, and this goes on and on and on. So this was iota square plus iota raised to 4 plus iota raised to 6 plus iota raised to 8. And this goes on and on till 100. So the last term will be iota raised to power 100, the iota raised to power 98. And we are making pairs. So all are getting cancelled. Okay. So this will also be get cancelled. This will also, and every term will get cancelled like this. So accordingly, what is left is the first term only, that is 1. Any doubts, anyone?
No, sir.
Yeah. Because all pairs will be found like 2, 4, 6, 8, and 2, 4, 6, 8, and 10, 12, and 14, 16, and then 18, 20. Similarly, there will be pairs which will be cancelling each other. Let's go to next question. Why, if omega is the imaginary cube root of unity, then what is? So we have that information that omega is the imaginary cube root of unity. Okay, so we have to find out 2 minus of omega plus 2 into omega square raised to power 27. Now let's first simplify this. How we can simplify this? As we know from our previous knowledge that 1 plus omega square is 0. So let's substitute omega square from the equation. Okay. So what is omega square is minus of 1 minus of omega. Let's put the value of omega square uh, plus 2 into minus of 1 minus omega raised to power 27. Further solving this 2 minus omega minus of 2 minus of 2 omega raised to our 27. So 2 cancels 2. This becomes minus of 3 omega raised to power 27. Now, uh, if there are two terms like a b raised to power n, this can be written as a raised to power n into b raised to power n. Okay, because the power is common. So power can be written separatively. So minus 3 raised to power 27 into omega raised to power 27. Now omega 20 raised to power 27 is the multiple of 3. So we are getting an hint that we can write it as omega raised to power 3 into 9. So 3 into 9 will become 27. It is the same. So what we have done just now, if like there is a raised to power mn is written, so we can write a raised to power m and to the power a raised to n. Okay. So this is the property that we have just used here. Clear? Any doubts, anyone? No doubts?
No, sir.
Omega cube is 1. So this will become 1. 1 raised to power 9 will also become 1. So the answer will be, and now minus sign can also be written outside. If the power is odd, the minus sign will remain the same. Otherwise, if the power would have been even, then the negative sign would have been uh, collapsed or vanished. Okay. Why? Like minus 2 raised to power 4 is plus of 2 raised to power 4. Minus 2 raised to power 5 is minus of 2 raised to power 5, because 5 is an odd number. Why? Like minus 1 get multiplied 5 times, then it will become minus 1. Okay. Minus 1. So this becomes plus 1, this becomes plus 1. What is remaining? Minus of 1. That is why. So minus will remain, and 3 raised to power 27 should be our answer, which is option number D. Any doubts, anyone? This is the previous year question asked in NDA 2021, 2011, in the first NDA paper. Okay, it's easy, just you have to remember the properties. Properties are very important. Clear? Any doubts?
No, sir.
So as we have earlier discussed that we have to remember also what is minus of omega and minus of omega square. So that if we see any term, then we can directly spot. So what is this? Minus of omega square. And what is this particularly? The term inside the power. This is basically minus of omega. So let's rewrite z. Now this becomes minus of omega square raised to power 107 plus minus of omega raised to power 107. So solving it further, the power is odd. So omega square into 2 into 107, that will become 214. and power is odd, so the negative sign will remain. Omega raised to 107. Now let's solve 107 to 14. So we know as omega 3 is 1. So if it is going to be the multiple of 3, then it's going to become 1. Otherwise, if there is any remainder left, so that the remainder will be particular power of omega. So 2 raised to power 214 divided by 3, 2, 3 7 is 21, 4, 3 1 is 3. So it is remainder 1. So how we can write 214? 214 now can be written as 71 into 3 plus 1. Now we know that omega raised to power 3r plus 1 is omega only. Why? Because this will become 1 and omega raised to power 1 will be left. So same is the case with here also. So z is equals to minus of omega minus of, now let's talk about 107. 175 17 है ना, 17 15 2 is left, so omega raised to power 2 will be the power. Now taking minus common, omega plus omega of square. Is that clear? How have I written omega and omega square from these big powers? Is that clear or should I
Yes,
explain?
sir.
Clear? Okay, so we have known from the properties that omega and omega square is called 1 plus omega square is 0. So omega plus omega square is minus of 1. So if this is minus of 1, minus minus becomes plus 1. The answer should be D. Any doubts, anyone? Okay.
No, sir.
I guess they have given a wrong answer. Okay. We have given a wrong answer. They are not wrong. So the complex number is z is equals to 1. But the question is asking what is the imaginary part of z. So please read the question completely. Don't do silly mistakes like me. So our yeah. So our answer was, our complex number was z is equals to 1, which is 1 plus 0 iota. So what is asked? That what is the imaginary part of z? So the imaginary part of this is 0. So on the answer should be A. And in the solution given, they have solved using a different method, applying de Moivre's theorem, which will be more complex for you to understand. No, not to understand, but to solve, and it will be more um, drudgery to do in the previous year, to do in the NDA paper. It will consume a lot of time. That's why you need to be very smart while reading the question and analyze the question and think for a smart and fast approach so that you can solve it in less time. Clear? And what is done here there is that simply they have found it out modulus of z and also the argument of z. And then they have found out the polar form, and thereafter they have applied the de Moivre's theorem by multiplying 107 into this. Then they have simplified the angles further and solved further. Clear? Let's move forward with discussion. The common roots of the equation, which is given to us, z cube 2z square plus 2z plus 1 equals to 0, and 2017 e raised to 2018 plus 1 equals 0. So there are, how many roots for this particular cubic equation will be? How many zeros will be there for this cubic equation? How many roots for how many value of z? This particular equation on the left hand side will also be becoming 0. Simply tell me what is how many roots are there for a quadratic equation? 1, 2, 3, 4, 5. How many? If the degree is 3, then there will be how
Three
many roots?
roots.
3 roots. If the degree is 2018, how many roots will be there? 2018 roots will
Okay.
be there. So we cannot discuss about 2018 roots, but we have the uh, the like power and strength to discuss about three roots. So if there is any root given to a cubic equation given to you for solving, then simply first go for put, if the constant is zero, then put the root as 0. Otherwise 1 plus minus 1 plus minus 2 and plus minus 3. And one of the this is the hit and trial method. Okay, this works most of the time with the cubic equation. So here from the observation itself, it is clear that there is a constant number. So z cannot be 0, right? So let's put plus of 1 first. So 1 raised to power 3 plus 2 into 1 plus 2 plus 1. So this becomes 5, which is not equals to 0. So z is not equals to 0. Now let's put 1. Now let's put z is equals to minus 1. Let's see. Minus 1 raised to power 3 that becomes minus 1 plus 2 into raised to minus 1 raised to power square plus 2 into minus of 1 plus 1. That's all. This becomes, so this minus of 1 square becomes positive. So 2 minus 2 becomes 0. Yes. So we have one root. So after you have find it out one root, simply now we know that this particular equation is having a root which is z is equals to minus 1. So basically z plus 1 is one factor of this equation. Let me explain you again by giving a different example. In quadratic equation, if this is a quadratic equation with having roots as 3 and 1. So if there are these roots, so we can write x square of minus of 4x plus 3 as x minus of 3 into x plus of 1. So from this particular equation, we can know that x minus 3 is a factor of this big term. So x minus 3 can completely divide this quadratic equation. Is that so? Are you able to understand what I'm trying to say? That this is the factor. This is a factor of this function. Clear? Why factor? Because if we will divide this particular term with this, then there will be some absolute value coming out with no remainder left. Clear? Like 12 is equals to 4 into 3. So 4 is the factor of 12, right? So similarly, x minus 3 is the factor of this. Clear? Don't sleep. Okay, let's go. Okay, so similarly, if z is equals to minus 1 is the root of this cubic equation, z plus 1 has to be factor of this big cubic equation. So if it is a factor, then it will divide the remaining cubic equation completely. So let's divide it and find out what is the other factor. So how we can find the other factor? Like if we divide x minus 3, so if we divide basically 12 by 4, then what will be the answer? 3. 3 is the other factor. So similarly, we are doing the same here. Okay. So z cube, first of all, do you know how to divide two equations? Anyone? So you will simply have to look on the variable part. Hmm. So the variable is z here. So and take the first equation. Write the equation in decreasing order of the degree of the variable. So we have done so. Now, first of all, take the first leftmost term and try to make it equal down here. So for making z cube here, we have to multiply z plus 1 to z square. This will become z cube plus z square. Now do one thing, change the sign. This will get cancelled and this is, let's solve the remaining. Okay. Now to again make z square here. How can z square be made here? By multiplying z. Okay, if you multiply z, then it will become z square plus z. Change the signs. This will become z plus 1. Now to make z plus 1 here, simply multiply with 1. Z plus 1. So yes, the remainder is 0 here. And the other factor is z square plus z plus 1, which is known to us, right? Its root are omega and omega square. So the one root is -1. Other roots are omega and omega square. Now let's try all of these three roots in the second equation which is given to us. Clear? Any doubt till now? Now we have three roots, minus of 1, omega and omega square. And the other equation is x z raised to power 2017 plus z raised to power 2018 plus there was something else also. Plus 1 is equals to 0. So let's put minus of 1 first. So minus 1 raised to power 2017, which is the odd number. So it will become minus 1 itself. It's an even number, so it will become plus 1, plus 1. So this will become plus 1, which is not 0. So basically, minus of 1, z is equals to minus 1 will not satisfy. Now let's check for z is equals to omega. So omega raised to power 2017 plus omega raised to power 2018 plus 1 is equals to 0. Now, 2017, we know 2018 is a multiple of 3. So for checking anything is the multiple of 3 or not, we will have to just sum all of the digits. So 2 plus 1 plus 7. So 2 plus 1 becomes 3 plus 7, that becomes 10. So it's not a multiple of 3, 1 will be left. So we can write this as omega. Now 2 plus 1 becomes 3, 3 plus 8 becomes 11. So 11 is not a multiple of 3. If you divide 11 by 3, then 2 will be the remainder. So this becomes 2 square plus 1 is equals to 0. Now, this is clear. 1 plus omega square is 0. So LHS is equals to RHS. This is one common root. Now let's check for omega square itself. So if omega is satisfying, definitely omega square will also be satisfying. But let's check why to guess. So putting z is equals to omega square this time. So omega square will make it 4034, and omega square this will make it 4036 plus 1 is equals to 0. Now let's check whether this is a multiple. This 4034 is a multiple of 3 or not. So 4 plus 3 is 7. 7 plus 4 becomes 11. So 2 will be the remainder. Omega square plus 4036. So 4 plus 0 plus 3 plus 6. So this becomes 7 plus 6, 13. So what will be the remainder? Let's check. 3 into 4, 12, 1. 1 will be the remainder. So omega plus 1, which is definitely 0. Omega square plus omega plus 1 is equals to 0, which is equals to right hand side. So this is another root. So what are the common roots we have find it out? Omega and omega square, not minus 1. So there are two common roots, omega and omega square. So let's check and take the right answer. There are no options. So these are omega and omega square. Let's check the answer. Yes, it is so. They have used a different method where they have simplified the cubic equation then solved for the remaining. I find it out that to be simpler, so I explained that using the division of two functions. Any doubts, anyone? No doubts? See, mathematics, you have to study and you also have to read by yourself after the class and revise the concept and formula. Then only after chapter and chapter you are going to understand things. Otherwise, they will you not be able to understand if you don't study. So, studying the next question. If A is a set where X is a complex number and The equation is x raised to power 3 minus 1 is equals to 0. So what will the elements in set A? So there are three roots for this cubic equation. Basically, x cube minus 1 is, so we solve x is 1's cube root. So this will be 1 and omega square. Three elements in set A. In B, x square plus x plus 1, x belongs to complex number. So there are two roots here, omega and omega square. Now where z is a set of complex number, then we have to find out the intersection. Intersection means common element, which are omega and omega square. So this is omega and this is omega square. Yes. So B should be our correct answer. Yes, it is the case. Clear in doubts, anyone? No doubts? Then let's move forward. Now we have to discuss about nth roots of unity. Till now, we have discussed about the square root of this and the cube root of this. And also we have discussed about cube roots of minus of 1. So what if we have been asked about the 1 by nth root of this, whether it is 2 and whether n is 2, 3, 4, 5, doesn't matter. So if we have to find out one formula for this, how we can go ahead. So first of all, for finding that, we had to find out one as a one complex number's polar form. So for finding out z is equals to 1 plus 0 iota's polar form, the magnitude of the same is 1. The argument of any purely real number is 0. So, okay. And also we can write argument of 0 as 2 pi. 2 pi into r, where r is an integer. So for sake of our convenience, because we are going to consider different things, so we are considering 2 pi r. Now let's write one is in the complex number, in the polar form. So cos of 2 pi r plus iota to sine of 2 pi r. So this is basically z, which is our 1. Now, if we have to find out the nth root of this, so let's take its root on both sides. Now, on this polar form, we know we can apply the de Moivre's theorem. So, 1 by n will get multiplied to angles. So, this will go cos 2 pi r divided by n plus iota sine 2 pi r divided by n. Now, please don't forget that r is an integer. And if we have to find out, like, if we had to find out the cube root, the 1 by 3 root of any unity, so there will be 3 roots. If we have to find out 1 by nth root, so 1 by nth root will have n number of roots. Okay, n number of roots will be there. Okay, so is there any doubt in this concept? Any doubts? This is important and simple. If you understand this, that how have I written every step. So now let's discuss about the properties of nth root of unity. So nth roots of unity form a GP with common ratio e raised per iota 2 pi by n. Okay. So wherever, like, before going to properties, let me solve a question for you. So this is a question, this is the example. If fourth roots of unity are basically, now what we are finding, 1 raised to power 1 by 4, and there will be 4 answers to it, which are z1, z2, z3, and z4. We have to find out using our solution method. And then after finding out, we have to square them all and add. So let's look into it. One can be written as cos of 2 pi r raised to power plus iota into sine raised to power 2 pi r. This is 1. And we are finding out fourth roots of unity. So 1 by 4. Okay. Now this can be rewritten as cos of 2 pi r divided by 4 plus iota into sine of 2 pi r divided by 4 again. So this becomes pi by 2. Cos of pi by 2 into r plus iota into sine of pi by 2 into r. Now, as we know, if we are finding out fourth roots of unity, so there will be four roots, and r is an integer. R is a positive integer. Okay, R is a natural number. R is a whole number, sorry, non-negative integer. So we can take R as taking, and we can only take R as four values. Why four values only? Because there will be four roots only, right? This is 1 raised to 1, sorry. This is basically 1 raised to what? 1 by 4. So taking R as 0, 1, and 2. How many are? 3. We can also take one more R. So 1, 2, 3, 4 number of R. So first of all, taking R as 0. So if R becomes 0, so the one root will become 1 fourth roots of unity will become cos of pi by 2. This will become 0 plus iota sine 0. So cos 0 is 1, iota sine 0 is 0. So this becomes 1 only. Okay, now let's discuss about another fourth root of unity when we take r is 1. So this becomes cos of pi by 2 plus iota to sine of pi by 2. This becomes 0 and this becomes 1. So answer is iota. Now let's talk about another fourth root of unity. Now this time r is 2. Here r was 1. Here r was 0. Now we are taking r as 2. So if r is 2, so the 2 will cancel and this will become cos of pi plus iota into sine of pi. Now cos of pi is minus of 1 and sine of pi will be 0. So the answer will be minus of 1. We take r as 3 and we are finding the fourth root of unity. Then if r is 3, then it becomes 3 pi by 2. Cos 3 pi by 2 plus iota into sine 3 pi by 4. Now we have to understand, sorry, 3 pi by 2. Now we have to understand what is 3 pi by 2. That is basically 270 degrees. So, uh, so if we, this is the sine curve. Okay. This is 1. This is minus of 1. This is 0 degree. This is pi by 2. This is pi. And this is 3 pi by 2. And this is again 2 pi. So on 3 pi by 2, sine is minus of 1. And on cos 3 pi by 2 will become 0. Okay. On all odd multiples of pi by 2, cos is 0. And on all even multiples of pi by 2, on sorry, on all even multiples of pi by 2, yes, that will become and natural, and all multiples of pi will become, all multiples of pi of sine will be 0. So this time cos of 3 pi by 2 will be 0 and this will be minus 1. So this becomes minus 5 iota. So basically our fourth roots of unity are 1 iota and minus of iota and, sorry, 1 iota and minus of 1, minus of 1 and minus of iota. Now we have to square them all and add. So if we square 1 plus 1 square plus iota square plus minus 1 of square plus minus of iota of square. So 1 iota square minus 1, minus 1 square becomes plus of 1, minus of iota square becomes iota square only, and iota square is minus 1. So this becomes 0 and our answer should be B. Any doubts anyone? This was very simple. Any doubts? No doubts? Okay, let's now move forward and discuss about the application of complex number in coordinate geometry. And this is important. Previous year questions have been asked from this particular subtopic. Now, if we have to find out the distance between 2 points in any argand plane, so let's say this point is representing Z1 complex number, this is representing Z2 complex number. We had to find out the distance between these two, then this particular different distance between these two will be AB length will be modulus of Z2 minus of Z1. Modulus means modulus. What is modulus of Z? If Z is x plus iota y, this is basically square root of x square plus y square. So after solving Z2 minus Z1, what are the complex number will be in front of us? We'll take the square of real part and the imaginary part. We'll add them both, and after that, take a square root, and that will be our modulus of Z2 minus Z1. That will be the length between these two particular points. So I hope this is clear. Coming to the next point, distance of a point from origin is modulus of Z. We have already discussed about that if there is any point x plus iota y, so this particular distance is modulus of Z. 3 points A, B, C will be collinear if AB plus AC, if AB plus BC is equals to AC. Yes. So if the length, like let's say ABC are 3 points on a line, it is for sure that AB length plus BC length will be equal to AC complete length. So for writing that in complex form, so Z1 minus Z2 modulus plus Z2 minus Z3 modulus should be equal to Z1 minus Z3's modulus. So 3 points are collinear. So this is the condition which has to be get satisfied. I hope that is clear. Any doubts? We are about to finish the chapter. Section formula. Now we have discussed about it earlier also. So internally, let's say this is another. Let's discuss about internal intersection first. If let's say there are 2 points R and Q, they're getting internally, and there's a straight line. Uh, draw a straight line properly. These are 2 points R and Q. R represents, sorry, P and Q. P represents Z1 complex number. Q represents Z2 complex number. There is another complex number in bit on this particular straight line represented by Z. So if we say that this point is intersecting PQ internally in ratio m is to n, then the Z complex number can be represented by m into Z2 plus n into Z1 upon m plus n. Okay, so this is the first point where internal division is happening. Now let's discuss about external uh, segmentation. Let's say there are 2 points P and Q. P represents Z1 complex number, Q represents Z2 complex number. And on this particular straight line, there is another point R which is representing Z complex number. So now this time our ratio will be m is to n. Okay, this is how will the ratio will be written like PR is to PQ. So RZ divides the line segment externally. So this is external division. Now this will be written as Z is equals to M of Z2 minus N of Z1 divided by M minus N. Clear? Any doubts, anyone? No doubts? So this is about application of complex number in coordinate geometry, and it is also very much required. The main concept is about the modulus, that this represents length. Okay, let's now discuss about more properties. First point is that if there is a straight line like PQ, P and Q are the point, and there's a midpoint R. So if P represents Z1 complex number, Q represents Z2 complex number, R represents Z, and if this is a midpoint, so Z complex number can be given by writing as Z is equals to Z1 plus Z2 divided by 2. Okay. Coming to the next point, if Z1, Z2, and Z3 are three vertices of a triangle, means if let's say this is the triangle and these are its vertices, Z1, Z2, and Z3. We have to find out the centroid. Centroid is basically if we join the medians. Median is a line which is connected to one vertices of a one vertex of the triangle going to touch the other edge of the triangle such that it divides it half. So similarly, so this particular point will be the centroid. To find out this particular centroid's complex number, we can sum the all of these complex number and divide them by 3. So this will be giving us the centroid of the triangle. Now let's coming to the next point. Z1, Z2, Z3 are collinear. Then using this determinant, we can find out any condition or any variable which is left. Otherwise, also we have discussed it earlier that we know particular order that Z1 is this, Z2 is this, Z3 is this. So we can find out the length between Z1 and Z2 and Z2 and Z3 and Z1 and Z3 and then use this particular condition to look for whether they are collinear or no. Clear? Any doubts, anyone? Okay, so this was about straight lines. Let's now also discuss one more last topic of complex number, which is important. That's equation of circle. Okay, let's now discuss the equation of circle. So, what is a circle? Can anyone tell?
No, sir.
No, no one can tell what is a circle. Circle is basically the locus. Circle is basically the locus made by a point which is equidistant from a center. So considering this is a center and this is a point on the circumference. So this will be always equidistant from the center. This particular distance will always be the same. This will be always the radius. So if it is going to be always the radius, so let us say that the complex number of the center is z naught and the complex number here is z. And z is equals to x plus iota y, where x and y are variable, and z naught is a constant with having, let's say, x h plus iota k. Okay, so now we can see the distance between these two is fixed, which is the r, which is the radius. So this is our equation of circle. Clear? And if in any case, if the center is on the origin, so basically this becomes 0 plus 0 iota, and now this time modulus of g is r. This is the equation of circle when the center is on origin. Clear? So this is all about today's class. Any doubts, anyone?
No,
No
sir.
doubts? Shall we call it a day now?
Yes, sir.
Okay, thank you. Good night, Jane.
Thank you, sir.
Thank you, sir.